and welcome back to Josh Does Math. In this video, this seems like a pretty easy problem. We're going to be looking at the continuity of the function root of x. So if you know anything about the basic functions, the root of x is going to look like this. Starts at the origin and goes like that over to the side. So just by looking at this, find the points of discontinuity. Well, I know it's continuous for everything that's over this way. However, it's not continuous anywhere over here. So that's going to be for all values of x less than 0. But how did I know that other than just looking at the graph? In other words, how could I prove that those are the points where this function is discontinuous? Well, I know that for a function to be continuous, the function needs to have a value for every x. The limit needs to exist for every x, and the limit value and the function value need to equal each other at every point. So the first thing I want to check for is making sure that the function actually has a value for every x. So what possible values of x could make this not give us a value? And the answer is anything negative. If I plug in something positive for x, I'll get some real number. If I plug in 0 for x, I'm going to get 0. That's the case right here, 0, 0. If I plug in a negative number for x, I'm going to get an imaginary number, not a real number, so therefore I don't get a value for the function at that point. So we're going to see whenever whatever's under the root, which is x, is less than 0, whenever it's negative. And we don't need to do any further algebra right here. This is our answer. Whenever x is less than 0, I don't get a function value. And since I don't get a function value, it doesn't matter. Let's say I could get a limit value for all these negative x's. It doesn't really matter because already one of our criteria was not met, and that's that the function exists at every point. So the fact that the function does not exist for all x's less than 0 means that this function is discontinuous for all x's less than 0. So that's the answer to this problem. Thanks for watching.